Okay, this is section 3.6. This is the last section in chapter 3, and this is solving quadratic equations by using the quadratic formula. So we have solved quadratics by factoring, by completing the square, and now we're going to solve them by using the quadratic formula. Now, on the test, you are going to be asked to solve a quadratic by each of those methods. So one question is going to be solve the quadratic by factoring. Another one would be solved by using the quadratic formula. Another one would be solved by completing the square. And then I'm going to give you one more where you solve it however you want. Okay. So make sure that you know how to use all three methods. Now, out of all of them, this is the easiest one, provided that you remember the quadratic formula, which is this: x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, the reason why I say this is easy is because you, number one, just like everything else, make sure that you begin with a quadratic, with an equation that's quadratic in form. It doesn't matter, like in 3.5 when we were completing the square, it doesn't matter if you have a leading coefficient here or not, but you're going to identify the A, B, and the C term, and then you plug those into your formula and crunch away. So this is literally plug and chug. Okay. So the first thing that we're going to do is make sure, do we have an equation that's quadratic in form? And number one, it is quadratic in form. Okay. So I want to identify my A, B, and C. So A is 10 because it's ax squared plus bx plus c. B is a negative 1, and c is negative 3. All right, so we're going to plug this in. X equals minus b, so minus a minus 1. Do not take shortcuts. Fill in everything appropriately. Plus or minus the square root of b squared, so that's minus 1 in parentheses squared, minus 4 times a times c all over 2 times a, which is 10. Okay. All right. Now, that was a hard part. Now let's clean this up. Negative minus a negative 1, that's just 1, plus or minus the square root of negative 1 quantity squared is 1. These two negatives are going to turn positive. So 4 times 3 is 12. 12 times 10 is 120. All over 20. So this is 1 plus or minus the square root of 121 over 20. Now, let me make a comment about this. What I want you to pay attention to is I want you to pay close attention to the type of number. At this point, when you clean up everything inside the radical, pay attention to the type of number you get underneath the radical. Okay. So this is 121. So that's a perfect square, right? All right. So this is going to be 1 plus or minus 11 all over 20. Okay. Now I have to split my answers apart. So I'm going to have 1 plus 11 over 20, comma, 1 minus 11 over 20, because I can simplify these numbers. That's why. So this is 12 over 20, and then minus 10 over 20. So 12 over 20, I can divide top and bottom by 4. So that's 3/5. And then minus 10 over 20 is just going to be minus 1/2. So my solution set is minus 1/2, 3/5. Okay. So we have, so the type of solution that I have here are two rational solutions. We have a perfect square underneath the radical, and that gave us two rational solutions. There's a reason why I'm pointing this out, and we'll get there in a minute. Okay, number two. This is not in quadratic form. So I have to move the 3x over. So 3x squared minus 3x plus 5 equals 0. Okay, now let's identify our A, B, and our C term. So A is 3, B is a negative 3, and C is 5. All right, so here we go. So we're going to plug and chug. X equals minus a minus 3 plus or minus the square root of minus 3 quantity squared. So minus 3 in parentheses. Minus 4 times A times C all over 2 times 3. So 2A. Okay. All right. So now minus a negative 3, that's just a 3, plus or minus the square root. Well, this gives me a 9 minus, well, 4 times 5 is 20. 20 times 3 is 60, all over 6. Okay. So 3 plus or minus negative 51, the square root of negative 51 over 6. So now, let's see. All right, so 51 breaks apart into 3 and 17. Neither of those are perfect squares. So I can't break that apart anymore. Okay. So this ends up being, oh, sorry. No, it's not. So the only other thing that I can do here is break this apart. So 3 over 6 plus or minus. Now, the negative is going to come outside as an I, but remember that we can't do anything with the square root of 51. So this is 1/2 plus or minus the square root of 51 over 6I. And then put this in set notation. So 1/2 plus or minus, and just repeat this answer. Okay. Now, this gives you two non-real solutions. They're non-real solutions because you have an I in your answer, which means you can't calculate a number and know where to go on the graph to plot that point. Okay. All right. So now let's look at number 3. Now we have fractions. We don't like fractions, right? So the first thing that we're going to do is we're going to get rid of the fractions. So I'm going to multiply everybody through by the LCD. So my LCD for 2 and 3 is going to be 6. So I'm going to multiply everything through by 6. Well, 2 goes into 6 3 times. So that's 3x squared. 3 goes into 6 2 times. So we have 2 times 2x. And then here we're just going to have 6 times 2 equals, and then 6 times 0, which just gives us 0. Okay, so 3x squared plus 4x minus 12 equals 0. Okay, so now we're going to identify our A, B, and C. So A is 3, B is 4, C is negative 12. All right, now let's plug in and let's see what we get for our answer. And I'm going to skip ahead. I'm going to go ahead and plug these in and get our answer. Okay, so this is what you should have gotten. So again, recognizing what's underneath the radical, that is a non-perfect square. And so we end up with 2 irrational solutions. So when you have a perfect square underneath the radical, you end up with 2 rational solutions, which means this factored. Okay, I could have factored that and ended up with those answers. Okay, these other 2 do not factor. Okay, so we ended up with a negative number. So that means that we'd have 2 non-real solutions. When you have a non-perfect square, then you're going to end up with 2 irrational solutions, which means this is just going to be a decimal that keeps going on and on and on and on and on and on. And it'll never stop. So it's irrational. Rational means it would stop on its own. The decimal would stop on its own. Okay? All right. Now here's why this was important this is why I was stressing this out. Okay? So the discriminant is the b squared minus 4ac. It's what's inside of the radical. So when the discriminant is greater than 0, so when it's positive, you're going to get 2 real solutions. Okay? So if it's a perfect square, you get 2 rational solutions. If it's a non-perfect square, it's 2 irrational solutions. If your discriminant is less than 0 or negative, then you have 2 non-real solutions. That means you're going to have an I. If it's negative, you get a negative inside of the radical. So that means you're going to have an I. So they're 2 non-real. And if this equals 0, well, look, if it equals 0, then all of this is gone. And so you just have minus b over 2a, which is only one answer, and it would be one rational solution. Okay, so what they want you to do here is to find the discriminant. So we're going to look, we're going to identify our A, B, and C. So A for number 4, A is 1, B is negative 12, C is 36. So B squared minus 4AC, we're going to plug this in. So minus 12 quantity squared minus 4 times 1 times 36. So this is 144 minus 144, which means this is 0. So if it's 0, they want to know determine the number and type of solutions. So we got a 0, so we get one solution. And if it's one solution, the type of solution that we're going to have is a rational. So one rational solution. That's what I can say. Sorry. Okay, so one rational solution. Okay, now let's do the same thing for number 4. Now notice they're not asking us to solve it. They just want to know what kind of um, solution we're going to have. All right, so for number 5, A is 1, B is negative 20, C is negative 7. So B squared minus 4AC. So we're going to plug in. Okay. Okay. So here we go. So minus 20 squared minus 4 times 1 times minus 7. So this is 400 plus 28. So 428. This is not a perfect square. Well, let's see. 20 times 20 is 400. Make sure. So no, it's not. 21 is 441. So it's in between. So it's not a perfect square. So it's positive, but a non-perfect square. So we're going to get 2 irrational solutions. Okay. Okay. Now number 6, A is 5, B is 7, C is 6. So B squared minus 4 times A times C. All right, so 7 squared minus 4 times 5 times 6. So we get 49. So 20 times 6 is 120. And 49 minus 120, it's going to be a negative answer. So negative 71. And since it's negative, we're going to get 2 non-real solutions. Okay. Now, number 7, it's up to you, because since all you're doing is figuring out the B squared minus 4AC, if you want to deal with the fractions, you can. So A is 1/2, and I'll deal with the fractions, and I'm going to use a calculator, and I'm going to plug them in and walk you through. Okay, so B squared minus 4AC. So open parentheses, 1/2, square it, minus 4 times, oops, hang on a second, B squared. Let me wipe that out. B squared is 5/4, so 5 divided by 4, close your parentheses, then we're going to square it. So that's the B squared minus 4 times A, which is 1/2, times C, which is 1. Since it's 1, I really don't have to do this, but I'll put it in there. So B squared minus 4AC, it's negative. b squared minus 4ac. Okay, well, that's it. And then we're going to turn that into a fraction. And so we get negative 7/16. So b squared minus 4ac is negative 7/16. So again, we get two non-real. Well, I thought one of these was supposed to be 0. Oh, it was 0. Rational. We didn't get a rational one. Huh. Okay, well, whatever. Anyways, you get the idea. So you need to remember those. Okay. All right. Now, 8 and 9, always treat these like puzzles. So we're going to solve for the specified variable. They want us to solve number 8 for a. So I have to get a by itself. All right. So the first thing that I'm going to do is add b squared to both sides. And since we normally write our variables first, we'll have 4a squared equals b squared plus 8. Then we're going to divide both sides by 4. So we get a squared equals b squared plus 8 over 4. Now I take the square root of both sides. So a squared, now remember you took the square root of a squared, so you're left with the plus and minus. Now here I'm going to go ahead and split this up because I see that 4 in the denominator. So this is the square root of b squared plus 8, and the square root of 4 is 2. And this is my solution. This is my answer. Okay, so hopefully that one wasn't too bad. Now, number 9, we're going to solve for x. So what I need to do here is we're going to divide both sides by 2 pi. Now, 2 pi is a number. Okay, I'm going to flip this around. So x squared equals v over 2 pi. Okay, so now I'm going to take the square root of both sides. So we get x equals, don't forget your plus and minus. I'm going to go ahead and split this apart. The square root of v over the square root of 2 pi. Again, I'm not allowed to have a radical in the denominator, so I have to rationalize. So I'm going to multiply the top and the bottom by the square root of 2 pi. So now we get x equals plus or minus, well, in the top, that's just going to be 2 pi v, the square root of 2 pi v. And then in the bottom, well, anytime you multiply a radical times itself, then you just get the radicand. So this is just 2 pi. So square root of 2 times square root of 2 would be the square root of 4, which simplifies to 2. Okay, so a radical times itself is just the radicand, whatever is inside of the radical. Okay, all right. Now, let's look at this next one. So here, they want us to solve for y, but notice that y is a quadratic. It's y squared. So the first thing I have to do is set this thing equal to 0. So 1/4 z y squared minus 5y minus z minus x, excuse me, equals 0. I don't like the fraction there, so I'm going to multiply everybody by 4 so we can get it out of the way. So 4 times 1/4, that goes away to just leave us with zy squared minus 4 times 5 is 20y minus 4x equals 0. Okay, now remember when we complete the square, we're solving for y. I have to get rid of the z. So I have to divide everybody by z. Okay, so this is y squared equals 20y over z minus 4x over z equals 0. And let me split this apart. I'm going to rewrite it this way as 20 over z times y, because that's the coefficient of your y term. And then we're going to move the 4x over z to the other side. Okay, now we complete the square. Now we're going to take half of our b term, which is negative 20z, and then I'm going to square it. So 2 goes into 20 10 times. So we get negative 10z, but I have to square it. So negative 10 times negative 10 is 100. Z times z is z squared. So this is the value that completes the square. So plus 100 over z squared plus 100 over z squared. Okay, now on the left, you made this happen. As ugly as this looks, you made this happen. So what do you square to get y squared? That's a y. Then what did you square to get the 100 over z squared? Well, you squared a minus 10 over z. Okay. Now on the right side, I have a z and a z squared. So I just need to multiply the top and the bottom by z so that I get a z squared. So that's going to give me common denominators. So we have 4xz plus 100 over z squared. Okay. Now I'm going to take the square root of both sides. So we're going to be left with y minus 10 over x over z, excuse me, equals, don't forget your plus and minus. Now, there's an addition sign in between these two terms, and it looks very tempting. Ooh, I can take the 4 out as a 2 because that's a perfect square. I can take the 10 out from the 100 because that's a perfect square. Well, we can't do that because we're not multiplying them together. They're being added. So this has to stay together. But the bottom is a perfect square. So the square root of z squared is just z. Okay, one last step. Now we're just going to add 10z to both, 10 over z to both sides. So 10 over z plus or minus the square root of 4xz plus 100 all over z. And that's your answer. That one's pretty gross. That one is definitely gross. Okay. It's just the way it goes. Okay, now number 11, solve the application problem involving quadratic models. All right, the average weekly earnings E in dollars for a group of workers can be approximated by this quadratic, where X represents the number of years since 2004. Determine the average weekly earnings in 2007. Okay, if X, so we have this quadratic, but then it says X represents the number of years since 2004. So that means that when X is 0, that refers to 2004. If X is 1, that refers to 2005. They want me to find the weekly earnings in 2007. So when X is 2, that's 2006. When X is 3, that would be 2007. So that means X has to be 3. So all I'm going to do is plug the 3 in for X. Okay, plus 7.8 times 3 plus 555. Okay, now here I'm just going to crunch all this in my calculator, but I need to be very careful. So 0.12 open parentheses 3 squared plus 7.8 open parentheses 3 plus 555. And so the average weekly earnings in 2007 for a group of workers is going to be $579.48. Okay. Now, it said, in what year did the average weekly earnings reach $638? Well, here, this is E. They gave us the weekly earnings as $638 plus 7.8x plus 555. Okay, so that means I have to solve for x. They want to know in what year. Well, I have to find x so that I can determine the year. So I have to set this equal to 0. And so when I do this, this is going to be 555 minus 638, which is negative 83. And there's no way that I'm going to try to factor this. And there's no way I'm going to complete the square on this. So I'm going to use our quadratic formula. So I'm going to identify A, B, and C. So A is going to be 0.12. B is going to be 7.8. And C is negative 83. All right. So here we go. Let's see what we get. So X equals minus 7.8 plus or minus the square root of 7.8 squared minus 4 times A, which is 0.12, times C, which is negative 83, all over 2A, 2 times 0.12. Okay, so negative 7.8 plus or minus, now we're going to number crunch, 7.8 times 7.8. So I got, let me scoot this over, bring this down. and cover up the x's for just a minute. So this is going to be 60.84. And then we have these two negatives are going to turn positive. So 4 times 0.12 times 83. Okay, so that's 39.84 all over 0.24. Okay, so 60.84. This almost looks like a 9. 60.84 plus 39.84 is 100.68. Okay. Now, let's think about this for a minute. So, if we're looking for x, we're looking for the number for what value it is. I cannot have x equal a negative number, right? So, I'm first just going to check to see what is the square root of 100.68. Okay, so that's 10 point, approximately a little more than 10. Okay. So I'm not going to do 7.8 minus this radical because that's going to give me a negative number divided by a positive is negative. Okay, so all I want is x equals negative 7.8 plus, I just want the positive one, the square root of 100.68 all over 0.24. And this is not going to be an exact number. More than likely, it's not. So it's going to be an approximation. So negative 7.8 plus the square root of, oops, hang on a second. Let me, let's see, let me put all this in parentheses. Negative 7.8 plus the square root of 100.68. Let me get out of there, close the parentheses. That's the top. And I'm going to divide it by 0.24. So that's approximately 9. We're closer to 9. 9 years. So dot, dot, dot. What is the year at x equals 9? So that would be 2013. Okay. So we're going to say approximately 2013. That would be the year. Okay. All right. And let's see. All right. I'm not going to worry about this last problem. Okay. If it's in your homework, let me know, and then I can delete it from the homework set. All right. But that's it for chapter 3.